All right, this is the video for section 8.3, and in this video we're going to introduce two other similarity theorems, and they're going to be similar to the congruency theorems that we've already talked about in chapter 5. But the first one is the side angle side similarity theorem. So this operates the same way the side angle side congruency theorem works, where you have the included angle, or the angle between the sides. But the two sides they're not going to be congruent. They have to have the same proportion. And I probably just misspelled that, but that's okay. They have to have the same proportion. So if two sides of one triangle have the same proportion as two sides of the other triangle, and the included angle of those sides on both triangles are equal, then the triangles are similar. All right, so let's look at example 1 here. It says you're building a lean-to shelter starting from a tree branch as shown. You can construct the right end so that it is similar to the left end using angle measures and known lengths. Okay, so we want similarity. All right, well, the first thing we know is this angle and this angle are congruent. Okay, so that's a good start. So then what we have to show is this side and this corresponding side have the same proportion as this side and this side. Okay, so let's check. So let's do the first one. So is 6 foot over 9 foot, so is 6 over 9 equal to, and I'm going to put a question mark because we don't know, 10 over 15. Okay, so now all we're doing is simplifying a fraction. So 6 over 9 goes to 2/3. 10 over 5 also goes to 2/3. So these are in fact equal. So I can say yes, triangle FGH is similar to triangle ABC by the side angle side similarity. All right, so this theorem here, guys, we've already used this. We just didn't have a name for it. It's the side-side-side similarity theorem. And all it says is that if all sides of the triangle are proportionate. So all sides of one triangle to all sides of the other, all three sides of the other. If they have the same proportion, then by side-side-side similarity theorem, that means they are similar. All right, so let's do some examples. So this one here, we only know two sides, but we know the included angles are the same. They're both 90 degrees. So this would be by the side angle side similarity theorem. And I have to show that the proportion of this side to this side is the same as the proportion of this side to this side. Okay, so I can say is 24 over 18 equal to, and I'm going to put a question mark, 28 over 21. So 24 over 18, this is 4/3. 28 over 21 is also 4/3. So yes, they are. Now this one over here, we need to find the proportion of all three sides. Now the way these are oriented is a little bit challenging, so I'm just going to use this. So XZ to ZY, so XZ is 12 over YZ is 9. Is that the same as, and I'm going to put a question mark, ZW to ZX, so ZW 16 to ZX is 12, and is that the same as, question mark, XW to YX? So XW is 20, YX is 15, so if I reduce all these, 12 over 9 reduces to 4/3. 16 over 12 reduces to 4/3, and then 20 over 15 reduces to 4/3. So they all do have the same proportion. And so yes, they are by the side similarity theorem. All right, so let's look at example 3 together. So it says, is either DEF, this one or this one, similar to this one here? Okay, so we have to find out, are any of these two similar to this? So in order to be similar, all three sides have to have the same proportion. And we don't know what's what side corresponds to what, so I'm just going to do the smallest has to correspond to each other, the middle has to correspond to each other, and the large has to correspond to each other. So all three of these have to have the same ratio. If two have the same ratio and one has a different ratio, then they are not similar. Okay, so I'm going to say is 8 over 6 equal to 12 over 9 equal to 16 over 12. All right, so I want to reduce all these. 8 over 6 goes to 4/3. 12 over 9 goes to 4/3. And 16 over 12 goes to 4/3. So this, yes, is similar to a triangle ABC. All right, so now I want to see if this next one is. All right, so once again, I'm going to take the smallest sides first. So the smallest here is 8, and over here is 8. So I can say is 8 over 8. Sorry, I can't write 1, and I should put this closer to here. Is 8 over 8 equal to, and the middle one is 12 over 10. Well, guys, I can stop right there because 8 over 8 is 1. This is not 1, so these are not similar. So I can say no to that one. All right, so let's look at this figure here. Now, I'm big on color coding things, so I'm going to go ahead and color code the corresponding parts. So AB corresponds to DE, so AB is here, DE is here. BC and EF, so BC and EF, and then AC and DF, so AC and DF. So these same colored are corresponding. All right, well, I know I have an X right here, and I know I have an X right here. So I just need to set up one proportion, okay? Because I know all three of these sides have the same ratio. So if I can find the ratio between two of the sides, I don't have to worry about the third because I know it's going to have the same ratio. Okay, so what I don't want to do is I don't want to have both of these X's in my equation if I don't have to. But I don't have to. Okay, I know this side and this side doesn't have an X. So I can say 4 over 12 is 2. Well, this here looks a lot simpler than this here. So I'm going to say X minus 1 is 2/18. All right, from here, guys, we are going to cross multiply. So I can say 12 times X minus 1 equals 4 times 18. And make sure you put this X minus 1 in parentheses because we will need to distribute this 12 through. So 12X minus 12 equals 4 times 18 is 72. 12x equals 84. Divide by 12, x then has to be 7. All right, I want you to try to do this last example here on your own. We've pretty much gone over all of these, and then we'll go over them together. Okay, so let's go over these. So I just labeled my triangles 1, 2, and 3, as you can see, above them in red. And then I went and I highlighted all their shortest sides green, all their middle sides purple, and all their blue sides, or their longest sides blue, I'm sorry. And so I know if they are similar, then the corresponding sides are going to be, the small side with the small side, the medium side with the medium side, the long side with the long side. So I went and I set up proportions. So I did the small side first, medium side next, and then the large side. And, sorry guys. And after I simplified the short side and the medium side, I didn't even have to simplify the long side because I could already tell these aren't all going to have the same ratio. Okay, so 1 and 2 is out there, not similar. Then I checked 1 and 3, and I noticed that all 3 of them simplifies to 2/3. So they do have the same ratio. So these are similar. 1 and 3 are similar. And then I checked 2 and 3, and once again I did the short side, the middle side, the long side. And after I checked the ratio of the short side and the middle side, I realized right away it was a waste of time to even do the longest side because they were already not similar. Okay, so angle 1 and angle 3, this is my similarity statement. Now remember, you could have this in a different order, but if you do, just know that the order of this has to match it. All right, so on B, it says the shortest side of a triangle similar to a triangle RST is 12 units long. Find the other side. Well, RST, the shortest side, is 24. Okay, so I set up a proportion. This one would be for the medium one, and then this one would be for the largest one. Now, a lot of you guys can look at this and say, oh, easy. If the shortest one is 12, that means this triangle RST is just double that size, and then you just halve to each one of these. That would work too. So I found by doing math that the medium side would be 15 and the long side would be 16.5. And that would mean that all 3 sides would have the same proportion, so they would be similar.